All right, guys, so the first problem, you should notice that, what you're trying to solve for, x, is kind of locked up. It's an exponent right now. So you don't have any tools to strip that exponent off. But what you can do is put both sides in the same base. 456. 456 is not, you're not going to be able to put that in base 7. At least not with a nice whole number exponent. So I can rewrite 7 in base 10. 7 is 10 to the log 7. .456 is 10 to the log of 456. Now you've got a common base. So yeah, solve for x. Log 456 over log 7. If we set these two things equal. Okay, moving on to the next one. So on the next problem, I'll wait for you. On the next one, I'm going to go ahead and take 5 away from both sides. 3e to the 2x plus 5. Is it a plus or a minus? Minus? Plus 5? 32, take away 5, 27. Divide both sides by 3, good. So now here's where the wheels come off. You'll notice that the variable is up in the exponent, which kind of presents a problem, but we have some tools for bringing those exponents down. So the left side is already in base e. The right side, is there e to an exponent? E to what exponent gets you 9? E to the natural log of 9. Well, so right now on your calculator, try to find the natural log function. So we're going to write this as e to the 2x plus 5 equals e to the natural log of 9. Okay, find ln on your calculator though. So what is the natural log of 9 approximately? Okay. So if you take e and raise it to that power, you're going to get 9. Yes, you can find e on your calculator. It's probably second ln above the divide. Yeah, you just leave it like this. Now that you've established a common base of e, we're working with 2x plus 5 equals natural log of 9. No, that would be right. You could write it like that. So there's your exact answer. Yeah. Aiden? Yeah. So what I heard you say was, let's say you had 12 and you wanted to put 12 in base E. Sure. So let's say we had e to the 4x minus 13 equals, you want to do 9 again, or you want to do a different number? Okay. So 12. Sure, yeah. I mean, I'm looking at this and I notice, hey, the left-hand side is in a base of e. Sure would be nice if the right-hand side was in a base of e. Yeah. So natural log, that's the function that's going to tell you the exponent on e to get that number. Well, how do you remember what the log function does? Was there a rule that you wrote for that? So let's try. So we did this here. This is the exponent. You put on 10 to get you want to put a number in or a variable? Okay. To get x. So example, log of 57 is the exponent. You put on 10 to get 57. What do you think log of 57, Jacqueline, is between what two whole numbers? What makes you think that? 2 and 3. What makes you think 2 and 3? 1 and 2. Okay, 10 squared is 100 and 10 to the first is 10. So yeah, we're looking at between 57 is between 10 and 100. So the only thing different here, Jacqueline, is log deals with base 10. Natural log is base e. Okay. E is a number, roughly 2.7. So I can change everything I've got here. Careful. The exponent to put on base e to get x. So just common bases in mathematics are 10 and e. So your calculator has built-in functions to go to base 10, that's log, and a built-in function to go to base e, that's natural log. Grace? Okay. Absolutely, yeah, so it was like negative 1.4. Yep, that's great. Irina? Log of 9 divided by log of e. Yeah, so kind of interesting what Irina did, and it's correct. So you didn't ever use natural log, right? Okay. So let's say you're here and you really don't like to use base e. Well, in the first problem we did, let's say I don't remember what it was now. It was 7 to the x equals 456. 7 was turned into a base 10 number, 10 to the log 7. 456 was turned into a base 10 number, 10 to the log 456. So what if you wanted to take e and turn e into base 10? Well, 10 to the what is e? 10 to the log e. Now you've established a common base. What would you do to both sides first when you set these equal? Yeah, divide both sides by log e, so you got 2x plus 5 equals log 9 over log e. Then what to both sides? Minus the 5. And then what to both sides? Divide by 2 or multiply by a half. So that's an acceptable answer. Now, do you have to go through more steps? Yeah, you got to go through a couple more. Do I think if one side is in base e, do I think you should get comfortable using natural log? I do, but you've got some tools there, a couple ways to get to the answer. Number 3. Hey, so quick recap on 1 and 2. You're solving for x. X is, it's in the exponent. So you're trying to get access to that exponent. One way we've been able to really get rid of bases and bring exponents down, it was that step where I cross out the 10 here. I'm only able to do that once I've established a common base. And likewise on the second problem there, the common base was established at this step, and I got rid of e on both sides. So, how do I know when I'm going to use log or natural log? You're trying to solve for x. X is up in the exponent. You got to have a way to somehow bring those exponents down. That's what's going to cue you off to, oh, I need to be using log or natural log here. Okay, so 3, Aaron invested $2,546 in a savings account 12 years ago. Today the investment has a value of $4,563. It was compounded continuously, which means I'm going to deal with E. So the formula we have, A equals P e to the RT. This is your end. This is your start. R is your rate. And this rate is as a decimal. And T is time, usually in years. I know, I hate formulas, but there's one you can use. Why? Well, I don't mind them after you've gone through the thinking and you get yourself to a place where you have some understanding, but just to give you a formula and have you practice it, I mean, I can train a monkey to practice using a formula. I want you to be able to think about it, make some decisions. And you did think a lot. So here we go. Yeah, and not that formulas aren't nice sometimes, but I want you to think before. So, what do we know? What variables can we actually substitute in for? A is 4, 5, 6, 3, okay. 2, 5, 4, 6. T is what? 12. Do we know R? Okay. And T is 12. Okay. So, you've built the model. Now we're looking to solve. I do notice. What do you notice about the position of R? Exponent. So we're looking at establishing a common base. Base we're probably going to use is E, or you already see a base of E in there. So first step is divide both sides by. You can just leave it at as that fraction. Now it'll look messy, but that's fine. What is it approximately as a decimal? Okay. Next step. Elijah, what's the next step? Well, that's all right if you didn't do it correctly. This is in yellow is where we're at. Okay. What's the natural log going to help you do at this point? It's going to help you what? So you're looking at what we have in yellow. What do you notice about the right-hand side? Base of E. Now, what we're trying to solve for, is that up in the exponent? R, yeah. Okay, so you wanted this guy in base of E. Do you know the exponent you put on E to get 1.792? Now, what would you do next? Okay. Yeah, good, man. You got the common base. So solve for R. R is natural log of 1.792 divided by 12. And I should say R is approximately. We've already rounded once. What do you guys get when you divide the two? Now they ask for the interest rate. Yeah, roughly 5%. Some students at this point will struggle. Now, if R is 0.0486, is that 0.0486% or is that 0.0? Yeah, 4.86%. Because you'll notice in this formula, the rate is as a decimal. I have this squiggly equals because when we went from this guy to 1.792, we rounded. I wouldn't ding you at this point, but just using good mathematical practice there. Yeah. Hey, I think that's a great strategy if you've got a calculator there. To demonstrate how you found the answer, I would just explain it in a sentence. Let's see how we do it algebraically here. So Logan, your first step was you wanted to set them equal? I mean, you were looking at where they were equal? Okay. Well, as you explained it, though, in your calculator, you were looking at where they intersected. You were looking at where they were equal. So, you know what it looks like graphically? You're looking for the intersection point. Let's see how we could arrive at it algebraically. Okay, so 4. Logan's kind of talked me through the start of 4. He actually said he put both equations in his calculator. looked at the graph and was looking for the intersection, which I think is a great way to do that. So we're going to try to take this apart algebraically. So what do you notice about the placement of n? Exponent. I don't know if you guys have seen one like this before. Yeah. So this one we're going to get a little creative. So my goal is to get to a point where both sides are in a common base. What base do you think we're going to use for this one? 10. Okay. So what if, separate kind of problem, I'm going to use some different numbers here. Let's say you had 100 times, let's go with 100 times 10,000. 100 times 10,000. And you wanted to say 100 times 10,000 is 10 to the what? Now, I know you can get this answer real quick, but stay with me. 100 is 10 to the what? Squared. And 10,000 is 10 to the fourth. So 100 times 10,000, 10 squared times 10 to the fourth. What do you do with those two exponents? Add them, so you get 10 to the sixth. Okay. So this first one, 24,356 is 10 to the how do we convert 1.0475 to base 10? Okay. Okay. How would these two exponents get combined? Okay, those two get multiplied. And what about the orange and the purple? How would they get combined? Added. Okay. So the left-hand side can be written as 10 to the what? Now what? No, you guys said these two things would be. Now I can get rid of those 10s. Yeah. Yeah, I want to see those in two steps. I want to see that the left-hand side is all in the same base, the right-hand side is all in the same base. At this step right here, you've got two 10s on each side. Okay, so from this step to this step down here. Okay. Awesome. Well, I'm glad you guys are asking. Okay. So are we all? I think this was just. I rewrote the problem, right? That was this first step. I just rewrote the problem. Okay. So at this point in my head, I'm thinking, okay, if I could just turn both sides into base 10. And so I know, okay, if I could figure out that number in base 10 and that number in base 10, I think I'll be one step closer. So 24,356, I said was 10 to the log of 24,356. And if you got a calculator, I'm going to grab the decimal of that. So what is that? Allison, do you have a calculator? How much? Okay. All right. The next one I went to was this one right here. So I want to turn that into a base of 10. Well, I know that 1.0475. How would I find the equivalent of that in base 10? That would be 10 to the what? So Allison, agree or disagree? From blue to blue, equivalent or not? Correct. So we're just compare the two blues. Okay. So I've replaced blue with blue. The nice thing about the new one is it's in base 10. I was previously this guy right here was raised to the n. So I'm going to have my new, what I've replaced it with, also raised to the n. And the question I asked the class was, how would you combine these two exponents if you were going to simplify it? Do you... Yep. Hold on one sec. Let me make sure Allison's got her question answered. Okay. So talk to me. So like when we have our exponent rules, if you have x squared to the fifth, if I asked you to simplify that, that would be x to the 10th. So I'm doing that same thing here. I'm just using that properties of exponents. I want to simplify it. And another property of exponents that we're gonna use is if I had like x squared times x to the fifth, that would be x to the 7th, because you'd add them. So I want to get to the left side to a place where it's just 10 to the something. Only one single 10 over there. So we sit right here. If I'm going to combine these two, how does this guy get combined with this guy? Multiplication or addition? Addition. So we're halfway there. The left side is now written in base 10. We did the same with the right-hand side. No, if you can go right there, that's fine. Okay. Jason, we have now established a common, not an acid, but a, what? Base. Common base. So, you got 10 on both sides. We can actually get rid of it. Now, if you want to take these, each of those logs to decimals, that's fine. I think it makes your job easier at this point. And you're not building rockets yet. Someday, I'm sure you will. So let's go to decimals right now. What is that one? Give me 3 decimal places. What is it? 4.386. Okay. 7 or 6? So 7. Well, at this point, I'm less concerned, Malcolm, good question. At this point, I'm less concerned about the algebra you're doing to solve for n, and I'm ready for you to get me an approximate answer. The learning here, you could absolutely do that. Yep. Yeah, you could absolutely do that and just round once at the end. This guy is going to be n times what? 0.020. Okay, this guy was how much? And then the next one. Okay, which side do you want your n's on? You got 0.020 n on the left, 0.005 n on the right. You think on the left? Okay. So I'm sorry, you said n's on the left? Okay. Minus 0.005 n minus 0.005 n. So 4.387 plus 0.020 n minus 0.005 n is 0.015 n. And what do you get over there? So what is it about? 0.233. Let's go to 3 decimal places. 0.233. Now, what year did they start this? 92? 22? 2.3 repeating? Okay. Okay. Well, my guess would be you missed a parentheses when you went to finally evaluate it. We can look at that. Okay, so 2.33 years later. So they started this thing in what year? 22. So between what 2 years? 24 and 25. Between 1924 and... Does it say in what year will it happen? Yeah, so I guess we'd say in 1924 it'll happen. Okay, we can look at it. Number 5. Oops. We can go back.